Welcome viewers. Today we will start new topic, system of particles and rotational motion. In previous chapters we considered the motion of a single particle. Particle means a point mass of negligible size. Same results we can apply also on the objects of finite sizes, assuming that the motion of such objects can be described as a motion of a single particle. But what about the extended objects? Extended objects, example, chain, beam or any disc, wheel. How will you read the motion of such objects of finite sizes? System of particles, as it is written, every object is made up of many particles. So object as a whole is supposed to be said to be system of particles. To study its motion, we have to take the concept of center of mass. If particle size object is moving, then particle size velocity of which that particle, mass of which that particle. But what about extended object like chain? If this is the rod, then if you apply the force, then you are applying the force at this point. The object as a whole is moving. Where is the total mass of this point, this point, this point, or what? Center of mass is a point in an object where whole mass of the object is supposed to be acting. So the concept of center of mass makes the study of motion easier in case of extended objects like chain, or if in this position, suppose this is the chain, okay, then what will be its potential energy? Or if it is placed like this chain, then how will you consider which mass at this point of different mass, or the same mass if you consider all points, then heights are different. We will study the motion of extended objects by considering the objects as rigid body. What do you mean by rigid body, rigid object? Any pair of particles always remain at the fixed distance. Position of particle remains fixed. It doesn't change. Distance between any two particles remains fixed. The bodies are said to be rigid. Ideally, there is no such a rigid body. We neglect any change if it occurs. For example, if a steel beam we take, then we neglect the bending. Similarly, the twist is neglected. So no any object is perfectly rigid. What is a rigid body? In which the distance of all particles, the body is said to be system of particles made up of many particles. Each particle has its fixed position. The distance between any two particles is fixed. Its shape is fixed. Its shape cannot be changed. All rigid bodies, suppose we generally take what is a rigid body? All solid bodies are said to be rigid. Now, motion of extended bodies can be studied. How? How many types of motions? What is center of mass? This all we will consider in this topic. Firstly, we will consider types of motion a rigid body have. There are three types of motions a rigid body have. Number one, translational motion, then rotational, then planar, motion in a plane. What is translational motion? As per its name, the object, its transfer of object move from one point to other point. For example, if you see the object is of any rigid body I have shown, so I have taken this point A and this point B. Okay, if it is moving in this like this, I have to draw the object of the same shape. Almost I have drawn. Then translational motion is that motion in which here in this rigid body distance between A and B is same, and here this A dash, B dash, the same object, distance between it is A dash, B dash, here it is AB. Translational motion, this AB, A dash, B dash, and in any other new position, these distance between two internal points will always be fixed. Thus, we can say the line joining any two internal point will move parallel to itself. That motion is translational motion. Also, if the line joining the same point in different position like AA dash, I am talking about AA dash, is if it is a straight line as it is clear in the figure, then it is called rectilinear motion. You know what do you mean by rectilinear motion? We have read earlier, in motion in a straight line. So this is a straight line. This position number 1 and this position number 2, we have seen that AB and A dash, B dash both are parallel. In any of the new position, the line joining the two internal points will be always parallel. And if the line joining the same point is a straight line, then it is rectilinear motion. And what about if the line joining is a curve? Suppose from this point A and B I take, this is the situation here. We find I have drawn almost same like this. This is the distance is same. This is A dash, B dash. Okay. But the path is curve. Here this A, B and A dash, B distance, this distance and the line are parallel. Then it is a translational motion, but since A to A dash path is a curve, then it is called curvilinear motion. Okay, this is all about translational motion. Second type of motion is rotational motion. What happens in rotational motion? Any of the objects, suppose I have taken this object, is pivoted at a particular point. Pivoted means fixed and the axis passing through that point. The object, suppose this is the point P at the distance R, and if this is the point, suppose I take one point here, okay, at the different distance, we take the same A point and B point. If it is rotated, it is moving about this fixed point P, then what we observe that all the points situated at the object is system of particles, then all particles describe the circular motion about the fixed point. They move with the same angular velocity, we will discuss, but this A and B, their situation from the axis, their distance from the axis is different, then linear velocity is different. We have read V equal to R omega, and omega is same, that means more will be the velocity of point B as its distance from the axis is more. You know, in the merry-go-round, what happens? That person who is sitting at the larger distance from the axis feels more velocity, linear velocity will be more. Angular velocity remains same, but linear velocity will be more for the person sitting at the larger distance from the axis, and here for A, linear velocity will be less. What we'll find here, this VA will be less than VB since RA is less than RB constant. For constant omega, this will be true. So rotation means each and every particle moves around along the circular path about the fixed axis. Okay, what will be the position velocity, angular velocity of this point at the axis? 0. What about the rotational motion? Another thing, if you don't fix the object and you apply the sudden jerk like this, if you apply the sudden jerk like this, then object moves about the center of mass. Look here, if you apply the sudden jerk, then object will move about the center of mass like this. This type of motion is called spin motion. So rotational motion doesn't require the fixation or pivoting. If the object is not pivoted, then it will rotate if you apply the force, sudden force sideways. Have you seen the ceiling fan? That rotational motion. Have you seen the pedestal fan in which the axis is oscillating about the fixed line? In this way, you can have so many examples. Potter's wheel for rotational motion. Okay, this is all about rotational motion. Third motion is motion in a plane or planar motion. What we have observed here, that in the planar motion, suppose at this plane a wheel is rotating like this at this point A, which is situated at the distance r from the center. After some time, it is in the new position, rotating in the same way. We find that the point A comes here. Okay, here we find that at the center C, if you observe this center, if you say it's center of mass, then it moves along a straight line. Which type of motion this center of mass showing? Translational motion. And which type of motion this point A is showing? Rotational motion. So what is motion in a plane? Translational plus rotational motion. Okay, like the motion of a wheel. So all three types of motion today I told, that translational motion, rotational motion and motion in a plane or planar motion. We will discuss in detail along with few examples as numerical example how to count the number of revolutions. We have seen that in fan speed is given RPM. Then what is the meaning of RPM? How will you find its value? Numerical examples we will discuss in the next video. Today I discussed only system of particles, what is its meaning and types of motion. Okay, thank you.